Recall that for a function to have an inverse, it must be 1 to 1, which means it must pass the horizontal line test. You can see that y equals sine x does not pass the test because different values of x yield the same y value. However, if you restrict the domain over this interval from negative pi over 2 to positive pi over 2, you will have this piece of a sine curve. And if you only focus on that piece, it does pass the horizontal line test. So, on the restricted domain, negative pi over 2 to pi over 2, y equals sine x has a unique inverse function, and it's called the inverse sine function. And these are the two notations you can use for those functions, arcsine or sine inverse of x. So now we have a definition of the inverse sine function. We know that y equals arcsine of x if and only if sine y equals x. So we know that the domain of arcsine is negative 1 to 1. That is possible input values. And the range is negative pi over 2 to pi over 2. Possible outputs. So previously, when we were looking for all possible solutions for sine, we looked at the entire unit circle to get all possible solutions. Now we'll only look from negative pi over 2 to pi over 2, which graphically is the right side only of the unit circle. So only look at right side of unit circle for sine inverse x. So we'll use this property of arcsine or inverse sine to evaluate some functions.